All right, for the number 5, as you can see, is asking you, use the voltage and the current intensity, is the more or less is actually the same, that you already determined by this series circuit current to determine the resistance of the bulbs in series, okay? So actually this is to check which one is the resistance of both at the same time. So because this is a series circuit, let me just make it way easier for you. So it's just asking you for the resistance of both added because this is a series circuit. So if you guys look for Ohm's law series circuit, so the total resistance of the circuit, it will be always the addition of all the resistances. So you have, this is for the parallel circuits, this is for the series circuit. For example, for this one right here, you're gonna have like 3 different resistors, like the ones that we have. We have 1, 2, 3 different resistors. This is the power supply. This resistor is 10. This one is 35. This one is 15. What do you do? In order to obtain the total resistance of the circuit, just add 10 plus 35 plus 15. Easy peasy. 60. All right. For the one that we have in our example, the only calculation that you have to do, because it's not calculated automatically by the simulator. So you don't have to do the Ohm's law. It's easier for you. I just need to that you guys put resistance, total resistance, RT, total resistance is equal to resistance 1 plus resistance 2. And what do you guys need to do? You just need to add exactly, thank you, Carlos, exactly. You just need to add, so 10 ohms plus 75 ohms. All right. And the final value is going to be 85. Because it's a series circuit, the next day we will see that for the parallel circuits, it's totally different. For parallel circuits, you guys, you do have to apply a formula that is kind of complicated. So that's why we're gonna be using Ohm's law instead. We're gonna be using Ohm's law and the simulator, and that will help you a lot to do that part of the assignment. So for number 5, I was asking for the total resistance of the circuit. Sorry if I didn't put it like very clear here. So for the total resistance of the circuit is resistance 1 plus resistance 2 equals to 85. Okay. So answering the question of Jordan, so we don't need to put the substitute values and then solve the part. You can do it like that as well, because you have the total voltage, that is 9, and you have the total intensity also. The total intensity, it was the current, okay? It will be like 0.00 whatever amps. So with that, if you put the values in the formula, you're gonna obtain also the total resistance. You know what I mean? So that will make exactly the same value. Which one is easier? Because it's a series circuit, you know that you just have to add the values of each resistance in order to obtain the total one. That will make it easier. This one is the last part. You can make it like that, or you can make it like this. So intensity is equals to voltage divided by the resistance. So if you guys apply a little bit of math, resistance is equals to the voltage divided by the intensity. You know what I mean? So if you apply 9 volts, because it's the 9 volts, the total voltage, and you apply the total intensity, in my case, the total intensity was 0.0045 amps, 0.0045 amps. If you did everything properly, you should have more or less the same value, that is 85. Okay. And answering your question, Carlos, is this what electricians do? Actually, not only electricians, engineers that they are like doing the installations of a house, like all the people that are architects, they are like working together with electrical engineers in order to make sure that everything is properly adjusted and so on. Mechanical engineers, process engineers, any type of engineer that is that requires to do like electrical circuits for their assemblies or for their products, they have to do everything by hand or even do everything using the simulators. Okay, we use this type of programs because they're amazing, and also they allow you to export it and they allow you to check the real real aspect of the last or the final version and so on. Yeah, so the electricians do this type of things, and they use, as we already checked before, they know how to use these testers, these multimeters, in order to make sure that everything is safe for the people. Okay, so if you guys want to become electricians, you're going to be familiar with these guys, with these type of devices. They're amazing. They're super nice. Okay, you see the resistors in the real life, the switches in the real life, and this is super easy. You have a resistor, you have a LED. It is not actually a light, it's a LED that we're going to be checking the next day as well. Okay, in order to measure the different elements, the resistance, we need to measure in parallel. In order to measure the intensity, we're going to need to measure everything. So I didn't wanted to introduce you a lot of terms today, but actually the Ohm's law is going to allow you to calculate everything properly. So as you can see, we were able to learn without the Ohm's law, just using the formulas of the CDS circuit. Okay, so all the electricians know how to do all this stuff, because it's super important, to make sure that everything is properly adjusted in all the installations that they do. Okay, and that's basically everything for today, guys. So I'm gonna be putting together the video just in case. If you need help, you can always check the video at